Hello everyone. In this video, I want to talk about fill-in circuits. This is a very important topic to learn when it comes to electrical industry. Um, One of the first things you'll begin to learn, I learned this in my motor and motor controls class at my college. So let's begin here. So what we have here is this is called ladder logic. This is typically how PLCs are programmed, and this is typically how your electrical wiring diagram will be for um, be in a ladder logic format. Now there are other formats, but the most common, as it's one of the easiest ones, and the reason behind being called ladder logic is because well, it looks like a ladder in a way. It has these rungs here, and you can add another rung below, another output, and so on and so forth. And begins to look like a ladder. So a fill-in circuit, basically turning something on and latching it on without holding the push button. You can push the button, release the button, and that component will stay on. So in this example, we will have, uh, we can say a relay or a motor. I'm going to give you guys a quick rundown on how a relay works here. This will make more sense. So typically a relay, a electromagnetic switch, just like a push button. You press a push button, it closes the circuit, allows electricity to flow through and output. A relay, just like a switch, except it can be automatic. You don't press a relay yourself. You don't manually press it. It's just automatic once it receives a signal coil. Once it receives electricity coil, they will switch contacts itself. So for example here, they have winding of coil. You have an armature here. You have normally closed contacts and normally open contacts. Then you have a spring. That way the relay can return to its original position when it's de-energized. So for example here, give you guys a quick rundown on the fundamentals of electricity. When current is applied to a wire, it creates an electromagnetic field. Then if you have a magnet near that electromagnetic field, it will attract it. So for example here, when electricity is applied to this coil, to this winding here, creates electromagnetic field. It then attracts this armature, which is magnetic. We'll pull this armature down to the coil here. Because again, there's electromagnetic field around this. Whenever electricity is applied, pull this armature down. This is going to take the normally closed contact and then make it open and make the normally open contact closed. Will allow electricity to pass through. Okay, so how can we use this to create a fill-in circuit? So we have a push button here. This is typically your inputs. Inputs are on the left side of the ladder logic. Your outputs are on the right. This is an output symbol. This is an input symbol. We have a push button. When you push the button, this closes, allows electricity to flow through, and it goes to your output here. We'll say this is a relay. This is going to be the coil of your relay. Your coil of your relay is going to be this. So when your coil, your relay is energized, you're then take a normally open contact right here of the relay. This is going to be normally open contact of the relay. So this relay, we have it labeled M0, the output or the coil of the relay, M0. We're taking M0 of this relay, one of the normally open contacts, and we're going to seal the relay in. So when this is energized, again, the coil's energized, coil's here, and it's energized. Armature, it's attracted to the electromagnetic field. It pulls in, closes the normally open contact. This will close. Then electricity will come from here onto the normally open contact, the coil, and the coil will constantly stay energized at this point. And as long as the coil is constantly energized, this will stay pulled shut, keeping the normally open contact closed, therefore sealing it itself in. Then this push button can then release this push button. This circuit up here will be broken, but the electricity will flow down through here now, and the relay is energizing itself with its normally open contact. So again, this is your incoming power here. You have electricity coming in. Let's start over here. Okay, so incoming power on the left here. Circuit is now open, no electricity getting to the coil of the relay. Push button, you press the push button, it closes it, it allows electricity to flow here to the coil of the relay. Coil of the relay is now energized. It's going to pull the armature, close the normally open contact. We have the normally open contact of the relay down here. It closes, release the push button. Now electricity is this way through the normally open contact and energizing the relay, therefore keeping the relay on and sealing itself in. And then to break this circuit, to de-energize the relay, you could add a emergency stop push button, a normally closed one here. Then when you press the push button, open the contacts and de-energize this.